So, if you are somebody who is actually willing to learn system design and you have a lot of system design interviews lined up, then on this particular channel, we are going to start a brand new series where I, along with Ria, are going to do a few mock interviews. These mock interviews are going to solely focus on 45 to 60-minute system design round. System design can be very deep as well, but in an interview situation, you have to be precise, you have to pick up very specific points, and you have to take deep dives on whatever questions are asked from the interviewer. So, how to maintain that temperament, how you have to go about in a system design round, you will get absolute clarity in this particular series. Also, if you are somebody who is willing to learn system design and who is looking for a dedicated learning resource around high level design and low level design, around different varied topics from beginner to advanced level that can help you to crack your next system design round, then don't forget to check Algocamp. On Algocamp, we have a dedicated system design course on which you are going to get everything required for low level as well as high level design. It's a hand-on course and it also gives you a lot of clarity around cloud technologies, how you can solve machine coding problems and whatnot. Do check out the link in the description section below. And without any further ado, let's start the video.
Hi, Sanket. So let's quickly start your system design round. A couple of details before we actually start. First of all, it's going to be around 45 minutes round. So we will discuss first we will have a discussion first for the first 40 minutes. And then for the last 5 minutes, if there are any questions and if you want to deep dive into something more, we can discuss that. And apart from it, while you're designing the whole system for whatever problem we pick, I'll be asking a couple of clarifying questions in the whole process.
Okay.
So I may stop you in between asking a couple of questions. And if I need some more clarity on your design, I'll be doing that as well in your interview. So are
Makes
you
sense.
clear? Should we get started?
Sure. Yeah, we can definitely get started, Ria.
Okay, so what we're going to do is today we are going to design a stockbroker. So are you aware of any popular stockbrokers in India?
I guess we are referring to something like Grow, Upstock, Zerodha, or IND Money. These platforms.
Absolutely right.
Yeah.
So that is what the today's problem is. We have to build a stockbroker. Now, when
Okay.
I say that, know that a stockbroker responsibility, just to reiterate, is simply to make sure that the transactions and the buying and the selling, which is being initiated by the users, is being basically going as a request to the exchange. Okay. Now, exchange, it
Yeah.
could be NSE, it could be BSE. Now, you don't have to specifically build the exchange. You can already assume that there is an exchange that is available to you, which can basically take in your orders, and if they are successful, give you those responses. So that is already available. You don't have to build that. We're going to focus more on the stock broker part, right? How internally a application like a Grow or Zerodha would actually work, interacting with the clients as well as the stock exchange. Does that make sense?
Got it. Got it.
Okay.
So thanks for the clarification, Arya. I believe we can definitely very quickly jot down the functional requirements based on whatever you have actually mentioned here. So technically,
Mm-hmm.
we want to just focus on designing the stock broker platform, right?
Mm-hmm.
We can assume that APIs for stock exchange is with us. Stock exchange is given already, right? We don't have to more or less care about the stock exchange. That means like stock exchange mainly also does the order matching and everything. So all of that we
Mm-hmm.
don't need to care about. Don't need to care about order matching and all, and
Correct.
fulfillment. Okay, cool. And apart from that, I believe one good functionality to definitely take care for a stockbroker platform, something like Grow or Upstock, is that like whatever are the end users, they should be able to initiate an order, like to buy something and sell something, and those orders should be passed on to stock exchange, right? That should be at least a bare minimum thing that users should be able to place orders, buy or sell on the platform,
Mm-hmm.
and platform forwards it to the exchange. Okay.
Correct.
One clarification question that I would like to have here is that an order buy or sell can be of type limit order. That means of a specific price. If you want to set that always sell beyond this particular price or below this buy below this particular price only, or it can be a market order as well, as far as my knowledge goes with respect to stock platforms. So do we want to keep a support on around both like limit order and I would say market order, or we don't need to more or less care about that? Any clarification on that aspect?
Yes, ideally, what we would like is our platform to be able to support both. If we would like to buy something at the market price, ideally, we should be able to do that. But if we do have a limit order, that should be supported as well. I think in the API itself, we could have some way to, I would say, keep taken care of.
Okay, cool. So that makes sense. That makes sense. We can definitely keep an eye on that. Apart from this, I believe one good requirement would be that the user should be able to see the price of the stock as well. Then only they will be able to actually place a buy or sell and like make a decision for that. So I
Yes,
believe users should be able to see the stock price in real time,
correct.
right? And do you want us to have a functionality where users should be able to see historic price, that like maybe a chart system where you we are able to show that okay, how the stock has performed for the last 1 hour, 1 day, 7 days, last 1 month, something like that? Do you think that
I
is also
think we
something?
can skip that for now. For the functional requirements, I think this look good. Although it would be good to if we have time, we can discuss a bit about this towards the end. But I think for now, this functional requirements look good.
Okay, this maybe I can add in a good one. Cool. I believe we have a good set of functional requirements and quite a few one to actually wrap up. With that, I would like to quickly jump upon the non-functional requirements also, so that we can start getting some ideas on the system. I believe that this overall stock brokering platform is going to be kind of like a very hybrid platform where whenever the user wants to, let's say, do the buying or selling, I believe that the buying and selling should be kind of like done in a very highly consistent manner. Like
Correct.
I believe the buy and sell should be highly consistent, right?
Mhm.
When I say highly consistent, mean that I'm doing a, I would say, kind of like a trade-off with consistency and availability with respect to cap theorem. That maybe the user is not able to place an order for a particular stock, that would be still okay, but it should not be like the money has been deducted, they placed a buy order but they don't see that buy order being executed, or that buy order is lost. So that's why consistency is something that we should definitely would like to focus on. But on the part of, let's say, seeing the stock price, like looking at stock price, this part of the system should be kind of like highly available, right? User should be always able to see the stock price and the stock movements, right? There might be a chance that okay, the data that they are seeing is maybe, let's say, uh, 10 seconds old, or let's say 30 seconds old, or a minute old, and we will be able to push the data once we will be able to push the latest data as soon as we have, but they should be able to at least see whatever price has been there for the complete day, so that they can at least make an idea and make a decision on how the price is actually moving. So I would say that this stock price part should be highly available, and if we can make it as consistent as possible, that should be something we should try to look upon. Do you think these two are a good consensus to have?
Yes, I think that looks good. Can we also focus a little bit about on how many requests can we also expect, considering, let's say, we have 100 million users? What kind of traffic we can expect on our stockbroker?
Okay, assume that so I was about to come to this part, so let's do some back of the envelope calculation, right?
Mm-hmm.
That assuming that, let's say, we have total 100 million users, and I'm assuming that, let's say, 10% is our daily active user, 10% now, if I expect, that makes our calculation to go to 10 million users per day are going to, let's say, interact on the platform. So we have two main type of request. One is going to be, let's say, actually buying and selling, and one is going to be actually looking at the stock price. What we can definitely ensure is that looking at the stock price is going to be slightly a bit more traffic heavy side on our platform rather than buying and selling, because a lot of people will be monitoring the stocks but very less, or like the number of time they will be placing an order will be slightly less. Okay, so we can say that stock price looking part is going to be kind of like read heavy, right?
Mm-hmm.
And buying and selling is let's say not going to be that read heavy. Lesser reads will be there. Okay. So overall, you can see the platform looks more like a read heavy platform in a nutshell, right? So considering that we have 10 million daily active users, and assuming that, let's say, all of these daily active users is looking at our platform, so we'll try to get the maximum number of requests altogether, right? So let's say that these 10 million users are making per user, let's say every user checks price of at least 10 stocks, let's say maybe 20 times a day, right? 20 times a day at least. Like, this is kind of like the bare minimum that we are looking at. I'll try to calculate the peak load as well later. So 10 million users looking at 10 different stocks, because people keep that in their watch list 20 times a day, right? This makes our overall number of requests to, I would say, 100 million into 20. That takes it to 2,000 million, which we can, in a better way, would we can write it as 100 into 10 raised to the power 6. That's going to be for a million. And then this is going to be 200 into 10 raised to the power 6, which is going to be approximately 2 into 10 raised per 9. That is approximately 2 billion requests per day. 2 billion requests per day. And the peak load, we can assume that, let's say, the peak load is, let's say, at least 5x of it. So 5x is the peak load. That makes it 10 billion requests per day. And if we want to calculate it, say, in per second basis, then in one day we have 86,400 second. I'm rounding it off to 10 raised per 5. So 2 into 10 raised to the power 9 divided by 10 raised to the power 5. This comes out as 2 into 10 raised to the power 4 QPS, right? This is going to be the QPS during the peak load that we might have to handle, right? 2 into 10 is per 4 QPS is something that we would like to handle. I believe this will be the peak load. And we can say that the number of people, like the number of final buys and sells, are going to be 10% of it. So 10% of the will be the buys and sells. So 10% of it is going to be 2 into 10 is per 3 QPS is something that we should definitely try to handle, right? Is that a good assumption to actually get started with?
Yes, that is actually good. We can go ahead.
Okay, cool. Makes sense. With that, let's try to focus on both the flows one by one. And because of the fact that both the flows have different set of requirements, maybe we can try to actually design things in a specific way for each one of them. Now,
Mhm.
one thing is for sure that we have a dedicated exchange, right? We don't
Yes,
need to care much about this exchange part. Exchange is going to be something that is going to handle a lot of things for us, like matching the order and giving us, let's say, the order history and everything. But we'll see what all things we have to manage. We are going to have some end user clients,
correct.
right? We are going to have some end user clients who are going to actually interact with our platform. Okay, cool.
Mhm.
Now, definitely one thing that I would like to add, let's at least try to get all the functional requirements in place first. Then we can see how we can scale up the system to and complete the pending non-functional requirements as well. So
Correct.
any request that needs to come, because it's a financial platform, this needs to have very high. This can have a very high risk in terms of frauds and everything. So we need to
Mhm.
have definitely an API gateway in between that is going to
Mhm.
ensure that we have all the requests rate limited, authenticated, any kind of a fraud check or whatever we have to do. There should be an API gateway that should technically help us with that. Okay, so
Mhm.
that is going to be one thing, and the responsibility is going to be straightforward. Any kind of an authentication, any kind of rate limiting and everything should be done through this particular API gateway for any kind of a incoming client request. Okay, so
Okay.
that is going to be one component of the system, very bare minimum. Now, talking about the fact that now this client needs to first of all see the user data, right? Yeah, sorry, the stock data. User should be able to see the stock price. This is the first requirement that I'm trying to fulfill. Now, the stock price is going to be regulated by the exchange, and the exchange is going to technically give us the corresponding stock price. So technically what we can have is we can have a service in between, right? Okay, and this is going to be, let's say, price service. What is the responsibility of this price service? The responsibility of this price service is going to be one thing, that it tries to accumulate the data from the exchange for the current price of a particular stock, and then gives that stock price back to the corresponding client. So technically this price service has to do a communication to the client, and there needs to be some way it gets the communication through the exchange as well. So let's see first of all how the communication between this price service and the client is technically going to happen. Now this price service, the moment this price service somehow has the latest data from the exchange about the stock price, it needs to send it to the client. And there is a good chance that there will be clients who has already opened the page of the stock, and they will be expecting the new stock price. Let's say the stock price goes up and down, and whatever charting library on the client side is able to move it all together. So I believe like a there are a couple of ways in which we can do this communication. Let's say the client can again and again poll our price service, but polling will be very heavy on the price service. We can definitely discard that. Web sockets are something that is a good two-way communication, because then price service will be able to send the data back to the client. But in web sockets, generally we use web socket when client also has to send something to the server, and server has to send something to the client for a more two-way communication. This doesn't look more two-way communication to us. What client is going to do, client is going to technically subscribe, or let's say open up a stock page and expect the stock ticks to come up. So I believe a good way would be that there should be some sense of server sent events coming up altogether. These server sent events should be there, that we can actually ensure that the price service is actually sending to the client through this API gateway, in order to ensure whenever a new stock tick is there, this server sent event sends the data back. Now, there are
So,
a couple of. Mhm.
sorry to interrupt you in between. I just had like a couple of questions. You mentioned that you'll go ahead with server sent events over here, and you'll not be going ahead with the, I would say, the WebSockets approach. Do you think there are any substantial disadvantages of using WebSockets? Like, is there a reason why WebSockets won't fit in this scenario at all, and server sent events are something which is, more preferable? Like, why do you think server sent events are very suiting for this particular scenario?
See, like, to be very honest, both could have worked. What I believe is, first reason why I would not like to go with WebSocket is that WebSocket, as a I would say, overall connection platform, is mainly to ensure or facilitate that when there is a two-way communication. This doesn't look like a two-way communication. So first thing is,
Okay.
WebSocket might be an overkill. Second thing is
Mm-hmm.
that, let's say the client has opened 2 3 stocks on, let's say, the platform. Let's say we are giving them a way that they can add multiple stocks and open the charts parallelly, assuming for a moment. Then for every chart, if let's say for everything, for every kind of a communication that has to be driven from the server, if we will maintain a WebSocket connection, then the client has to maintain a lot of WebSocket connection through our to our server. This puts an overhead on the client side, and our client application might be overwhelmed with the number of open WebSocket connection. So I believe the number of open WebSocket connection should be kept as less as possible uh, for performance. I would say, to ensure the performance. And as of now, we don't see a requirement for WebSocket connection, because the client doesn't have to send something to the I would say, server. Maybe the only thing that client has to do is, maybe because the server sent event also has to set up a persistent connection, and on top of that persistent connection, the SSE happens. So while setting up the persistent connection, they can just set up that, okay, which stock symbol they want the latest price for, and that is it. The persistent connection can happen, and the data can come back. It's just that the client doesn't have to send anything else after the connection has been set up to receive the price. Hence, I believe WebSocket is something that we can definitely avoid as of now.
Okay. And so whenever a person or a client basically opens the stockbroker app, you can expect two types of clients to actually be. For number one is going to be somebody who's basically trying to look at the stock price for the very first thing in the day, right? So they're opening the app probably after a day, or right, or probably after 2 3 days. And the second type of client you basically has is a recurring user, right, who's constantly on the stock page and consistently trying to see the updation of the price, or if something has changed or not. So when you talk about SSE, what kind of scenario are we really dealing with over here?
Okay, so for now, SSC is going to technically work for, let's say, those clients which are, let's say, already on the page, like kind of like your client number two, which are already on the page. they were already looking at the stock price, and through SSE the stock price updates are going to come up for that particular day. For the first client, let's say the stock session has opened at 9:15, and
Mhm.
it's as of now, let's say 11 a.m. in the morning, and now somebody like client one opens a page. So they don't just need the latest stock tick update, they also need the complete day data, that how the stock has performed for that particular day. So we are going to add the requirement, like we are going to add the setup for this flow as well, that they are able to see the slight bit of history for that particular day of that particular stock. And once they are on the page, then the SSE should be established, and SSE is going to send them the latest stock ticks altogether. So that is
Got
something that we have to that we are yet to establish for client number one.
it.
Does that answer
Go
your
ahead.
question?
Yes, you can go ahead.
Yeah, cool. Now talking about the two-way communication between the price service, for the price service, this is going to be on the client side, but on the server side, now again, price service can maybe do a polling to the exchange, but exchanges are very I would say high. Exchanges are platforms which are already having a high amount of load, and they have to do a lot of processing. So polling the exchange again and again for a price update is again not going to be the best thing to go for. Ideally, what should technically happen is that the exchange should also send us the events for the stock ticks, that our price service should try to subscribe. Let's say there are, for example, I believe on NSE there are 5,000 symbols altogether. So what this price service should do is, this price service should subscribe uh, uh, kind of like an API from the exchange, which is again going to be driven by server sent events, right? That again, we do not need to again and again bombard anything to the exchange. Once this connection has been established between our price service and the exchange can keep on sending us the corresponding set of price updates altogether, right? So that is going to be something that we should have. And again, this puts slightly a lesser amount of load on the exchange, because then the exchange will not have to accept any request and process the request. Whenever there is a stock price update because of the buys and sell orders and the volume, then the update can be sent to the price service. And generally for platforms like Grow, Zerodha, they have to subscribe and let's say pay some good amount of money to this particular exchange in order to subscribe to these events. So this should be not a very I would say complex affair for these. The only thing is that with this particular infrastructure, we will be able to facilitate the new incoming stock ticks. For the existing stock tick, like let's say 1.5 hours of the complete trading day is gone, and let's say client number one, as you mentioned, is going to now open up the page, so they want to at least see some price updates altogether. So what we can actually do is that instead of price, so we can use single responsibility principle to ensure that the price service is only responsible for showing all the prices to the client. And because exchange is more or less kind of like an outer world I would say system, what we can have is we can have I would say, let's call this particular service as a exchange uh, and I would say gateway processor, kind of like this. What is the responsibility of this exchange gateway processor? There are going to be a couple of responsibilities. First, because this exchange is going to be on the outer world, this is outside of our, let's say, private network altogether. So this will be responsible for doing any external communication through the exchange. Any kind of an external communication should be facilitated by this particular exchange processor. Now what we can do is, the exchange processor is going to actually receive all the server sent events from the stock exchange like NSE, BSE, whatever we have. And then because this has already subscribed and this is again and again receiving all of the data for us, what we can have is we can have kind of like a storage in between, which is going to technically ensure we can have a storage in between that this exchange processor can actually send the data to. Like for example, 9:15 the trading session started, so exchange is going to start sending us the updated stock ticks. This exchange gateway processor is going to technically store that data inside this storage altogether. And let's say somebody like client one actually comes up, right? The client one is going to make a request that, okay, show me the last 1.5 hour stock price and the latest stock ticks. So for sending the last 1.5 hour stock price, the price service is going to fetch the data from this storage. And apart from this, there should be a direct communication between the exchange gateway processor and price service. This can be done maybe via some API call, right? That now the latest price update, that is being fetched from the exchange in the exchange gateway processor is going to be sent to the price service, and the price service is going to be using SSE to facilitate to both of the corresponding clients. Okay, so that is going to be one way. And this storage is again going to help us that whatever historic price update has happened throughout the day, the client one is able to at least see that, fetch that thing, and all the latest price updates are going to come up through this particular API. I would like to maybe add some API contracts for this particular interaction. But before I add some API contracts, any particular question that you have here?
Yes. Can you talk a bit more about what kind of storage you're going to opt for? That is question number one. And question number two would be, how would you really store the data? Like, in what structure are you really going to store the data in this storage?
Okay. So for this storage, I believe we would like this storage to be in a way that all the stock ticks for a particular timestamp, like at what particular timestamp and what particular stock symbol we are actually looking at. For that, we want to store the stock prices. And although it's not our requirement, but we had a good to have requirement of old price history charts and everything as well. So if we can have this storage, let's say something like a time series DB, right? Kind of like a time series DB, maybe something like time scale, right? That can be useful for us because we would like to actually see that uh, price for the last 1.5 hour or the last particular day, whatever has been there. And apart from that, maybe we can just to ensure that okay, the storage is not overwhelmed, because some stocks have a very high volume of I would say buys and sells. So maybe this particular storage we can shard based on, let's say, the stock symbols, that those stock symbols which have extremely huge amount of trading volume, maybe the top 50 or top 100 on Nifty, kind of like that, are in one shard, and those which are having lesser amount of volume are on the separate shard. So sharding strategy we can think about, but I believe a good time series DB we can actually opt in here for the storage.
And how would you really store the data? Can you take an example for any particular stock, let's say Apple, and let's say a price fluctuation that has happened for that particular stock?
So let's say, assuming, let's say something like Apple or something like, let's say, Infi, right? So what we can actually have is that we can have a table. So for example, as far as I know, timescale is based on top of Postgres. So we can have a table prepared that is going to be, let's say, a price history table, and inside this table, whenever a price update is going to actually come up, we can actually mention the time stamp of when the price update has come up and what price value we have actually got, right, for one particular symbol, right? And we can bucket it accordingly, right? We can have, if again it's a good to have requirement, but if we want to have, let's say, data for separate date, we can have the bucketing done, let's say, on every 3 hours or every day, kind of a thing as well. So the timestamp and whatever price value you have, we can have that, and maybe we can index it with respect to the timestamp, and whenever the user actually wants, we can show it with respect to the, in order of the right timestamps, like let's say from 9:15, then let's say next tick came up in 9:17, and so on. So however the price fluctuates, based on that we can send the data to the price service and then eventually to the client.
Got it. Okay, yeah, let's go ahead.
So that is there, and looking at the API contract, let's say, from all of this. So in order to subscribe to this, let me maybe write it here. So the API should technically look like this: that we should have, let's say, a get
Can you
request.
scroll up a bit, Sanket? I think it's not visible with your video. Like, you can scroll
Okay.
down a bit. It's being
Okay.
hidden by a
So
video.
okay, cool. I guess now it must be visible. So it should be a get request. One second. Let's not write it here. Let's maybe write it here.
Maybe you can write it in the middle. That is very clear. Or this is fine as well.
So it should be a get request, and in the get request, it should be to something like /API /v1 slash stock price. Okay, and in the query params, maybe we can send a symbol, something like, let's say, infi, right? And we should be able to see all the stock price history for Infosys, right? And also the moment we see the stock price history, this should also help us to subscribe to that particular stock, and any latest stock price update should also be sent via the SSE altogether. This is going to be one API that we can have in order to see the corresponding price history. If we want to have the filters and everything, that let's say for last 1 day or something, so we can have I would say time range, like we can have a parameter time range start, or let's say we can just have a parameter time range is equals to something like 1 day or 1 month, 1 month, or let's say 1 hour, something like this. These kind of time range values we can pass if we want bucketed data to be sent from our price service for historic chart viewing. This is going to be the API that we can have. Now, talking about this, now our one requirement is fulfilled, that we are able to see the stock price, and good to have requirement is also there. Now we should be able to place the orders. Now I believe the order placing responsibility should not go to the price service, again because of separation of concerns and single responsibility principle. And I believe we also want to do a couple of things, that let's say whenever an order comes up, we also would like to maintain an order history on our end, so that we do not have to again and again patch in things from the exchange and again request that, okay, what was the last 30 orders for this particular user. This will be a very expensive API to the exchange. So what we can have is, let's say we can have a separate mechanism built in, and we can maybe call it as something like a order management service, OMS. Sorry. Again, horizontally scaled. This is going to be an OMS. What OMS is going to ensure is that any kind of a buy or sell order call actually comes up from our client, that is going to be technically entertained by OMS. Now OMS is going to do a couple of things. First, whenever a buy order, actually buy or sell, whatever kind of like some order comes up, what it technically should try to do is, it should try to store that in a separate storage here, right? And there should be a separate storage coming up here, which is going to be the order DB, right? This is going to be the order DB, right? Now this order DB, why we are maintaining an order DB, again as I mentioned, that whenever we want to, let's say, get the order history of this particular user, we can try to fetch that from the order DB altogether, right? We can get it from
But
the order
Sanket,
DB altogether.
but Sanket, whenever you pass on a request to the exchange also maintains, what order has basically reached them. Why do you feel the need to have that information replicated in order DB as well when exchange already has that information?
There are a couple of reasons. First, during the trading times, like let's say for example in India, trade times is from 9:15, or let's say 9 p.m., 9 a.m. to 3:30 p.m. During the trade times, the exchange is already bombarded with a lot of requests, and for every request, most probably we have to pay the exchange as well. So we would like to keep the number of requests uh, coming back from the exchange as less as possible. Second thing, we are maintaining this order DB to also see a lot of historic data. Maybe we can have some kind of like a OLAP system, let's say build, or let's say some analytic platform built on top of this, where we can actually see what has been the user, I would say, history, or what has been the user interaction profile, any kind of analytics we have to do. For those analytics purpose also, we would like to maintain some data on our end. Whenever we have to see, let's say user wants to see their orders, they are able to see slightly bit more faster rather than us turning around from the exchange. So this is also going to help us. Apart from that, for any kind of a recon, that means reconciliation, later, let's say if any kind of maybe security or privacy aspect comes up, then we can also recon the part that, okay, this particular order at this point of time was actually recorded on our platform. So a lot of benefits we will get to store this in our order DB, and again this will decrease the amount of load also on the corresponding exchange.
Okay.
And talking about order DB, like I believe the order DB's nature should be, we should be able to support good asset compliance, because we don't want, because whenever somebody places an order, there might be a lot of operations going on. So either all of those operations should work or none should work. So I believe a good asset compliant order database should be there, and something like, let's say, PGSQL or some RDBMS maybe should be good here. We can have let's say AWS RDS, with using which we can deploy an RDBMS, which can take all the order data altogether. Now talking about this order DB, whenever a new order is going to come up, this new order is going to be received at the OMS. OMS is going to forward this order to the order DB. And for this order, the data structure is going to look something like this, that for each order, we are going to have a unique ID, that is order ID, as a primary key, right? We are going to have, let's say, the user ID who has actually placed the order. We are going to have the symbol, the stock symbol for which we have placed the order, maybe the timestamp when the order was placed, and we should have a status of the order, that whether the order is in a placed state, pending state, fulfilled state, cancelled state, and so on. Initially the status can be pending, so this should be probably some kind of like an enum. Now, apart from all of this, there should be one extra property that we are going to have, that is an I would say exchange ID, exchange order ID. What is this exchange order ID? Now, because exchange also maintains a database on their end, so let's say once our order management service is going to technically send the order data to the corresponding exchange, exchange is also going to store that on their end, and there is going to be a unique identifier for that particular order on the exchange side as well. So later, for any kind of a reconciliation, the exchange will not be aware, because this platform is, let's say, Grow. Similar to Grow, there are other platforms like Upstock, Zerodha, and so on. So exchange will only deal with the unique order ID that exchange has prepared. All of these other platforms, depending on what are their internal implementations, have to, I would say, moderate things on top of it. So this order ID that I have mentioned here, this is our own database's primary key ID. This exchange order ID is going to be the unique ID that is going to be given to us by the exchange. So initially, this exchange order ID is going to be null. Why? Because as of now, we have received the order and we are making an order entry inside the order database. Once this order entry has been added in the corresponding order database, what we can try to actually do is, after this, we can have, let's say, streaming system in between, because again, we do not want to directly bombard all the orders to the exchange, because exchange is already overloaded. So we should make sure that we are receiving the order, and once the order has been fulfilled, we can show the status update to the user. So there can be some streaming platform, like something like, let's say, Kafka. So what, after this, the order DB should technically try to do is that it should OMS should try to do is this should add the order to Kafka. And then this exchange gateway processor, what it can do is, this can have one more responsibility. We can have a separate service for it as well, or maybe because this is already our external uh, system that is this is a system that is interacting with everything external. So what this can do is, it can take one by one all of the orders, and it can try to put the orders in place to the exchange, right? And once it places the order to the exchange, exchange is going to technically give back an corresponding external order ID, and that external order ID should be then updated to our order database, right? That should be technically the flow. And again, even the exchange can take up some time to process the order. So if we have to, let's say, once the order has been updated, again, the exchange can send us the update about that order through maybe an SSE, or maybe we can have maybe some kind of, again, maybe we can poll the exchange to get the order status update, that okay, has the order been done or not, or maybe exchange can send it us through SSE. But order matching can take up a lot of time sometimes, because let's say there is an upper circuit. During an upper circuit, if you will try to buy more, nobody is selling, so that buy order might take maybe an hour to complete as well. So instead of using something like SSE or polling, I believe exchange should be given some kind of like a webhook to our exchange gateway processor, that whenever they have an order update, they can call this particular webhook, and this webhook will update the order status inside the order DB. This is going to ensure that, like, let's say we are not polling, and even for SSE, we have to maintain, let's say, a persistent connection. We can avoid that persistent connection. Whenever exchange has that order update, exchange can actually give us the corresponding order update through a webhook. So that is one way that we can identify the update of the order, and this should be the structure of the order DB altogether. Let me see if anything else needs to be done, and let's say how the API should look like. So this API should be, let's say, a post request to /API/v1/order, right? And in the request body, we are going to send the symbol of the order, right? We are going to send the order type, that whether it's a limit order, sorry, first of all, order type, that it's a buy order or sell order. And then I would say one more type property can be there, which will be, let's say, limit, or let's say market price, whatever is going to be. If in case it's a limit order, then we also need to send a price, that at what price we want to send, let's say, this particular limit order. And in case it's a market price, then this price property can be null as well, right? Apart from that, I believe exchange might be expecting a couple of things for the users as well, but the user ID and everything we can send separately in the header to ensure whatever authentication mechanism we have with the exchange. So this should be more or less our post API to actually create the order altogether. And if let's say user
I
want to see
think
their order
here,
status,
Saket, here I think in the post API we can also add the timestamp, like at what
we can
timestamp
have
you're
a
actually.
timestamp. We can have a timestamp of our platform that when we have received the order. But I believe it can be a conflicting opinion that maybe the because exchange when the exchange receives that order, the timestamp on exchange side might be different. So maybe in the response, like for the response of this post API, exchange can give us a timestamp that when they have received the order, and we can maybe play around with that timestamp. I believe our timestamp is not going to matter a lot with the for the corresponding exchange. But again, it will highly depend on what kind of an API exchange is exposing to us. It's an external government authority. If they expect us to send an timestamp, we can maybe definitely add that. But I believe it depends on what contract we do set up with the corresponding exchange. I believe because there will be a couple of more things as well. For example, I believe every exchange is going to give us some kind of like API key, a unique identifier for our platform. So to authenticate that, okay, we are a properly registered platform on the exchange and so on. So this depends on what kind of like contract we have with the exchange, I believe.
Okay. And another question is, so sometimes what happens in a stockbroker is that a client tries to place the order, and here in your case, it will pass through OMS and then it will be passed to the exchange. And let's say it's a limit order. I want to buy at a certain price, right? But that order never really gets processed, okay? And it will stay in our system. So what your current design does is that if there's an order that's in a pending state, it was accepted by the exchange, but eventually it never got placed. How do you want to deal with that data? Will it just sit in the RDBMS, like because it's going to be in the pending state forever? And how are you going to design that part and take care of?
Exchange is going to call us whenever they have an update. If let's say we want to ensure that we do not wait for this exchange webhook, maybe we can have a background process going on that maybe in a batch of orders takes an update from the exchange that okay, these were the orders placed in the last 5 minutes, what are the update for these orders. There can be a batch call that we can do with an exchange with a separate service which is again and again doing a recon with exchange. But again, this will add more API calls that we are going to make to the corresponding exchange, I believe.
But what if the order never gets placed? Particular part.
Ac-
So
Um, sorry. So I was saying that this exchange order ID is going to be something that is going to help us. If the order has been received by the exchange, we can have a contract between them and us that if we have received an exchange order ID, then the order has been accepted by the exchange. In
okay.
case we do not have an exchange order ID, what we can use is we can use our streaming platform that okay, the order that was actually picked up by the gateway processor and sent to the exchange, we have not received an exchange order ID for that. So that order we can do a retry for a couple of times, and let's say after a 4 or 5 retries if that doesn't work, then we can add that particular order to a dead letter queue, and maybe with a manual intervention or let's say again a separate process, we can retry those dead letter queues and or dead letter queue orders, or we can see what went wrong with that particular order. So there can be a mechanism for that. But again, some retry because of Kafka we can have those retries available, and using this exchange order ID we will be able to ensure that whether the exchange has accepted our order or not. If the exchange has accepted our order, it's now on the exchange that when they fulfill the order. I believe that would be something that we can go for. What do you think?
Okay, yeah, that sounds good. I have one last question, and then if you have any closing remarks for your design, you can maybe discuss that with me. So, if you will see in your design for price service and exchange gateway processor, there could be situations where the price of the stock is I would say changing quite frequently, right? And with that, there's only not one stock price; there could be multiple stock price, and that could put a lot of load on your price service, right? And it could be bombarded with a lot of price changes. Do you think having a simple API, which is just sending the data updates, would be very optimized in this scenario?
Yeah, so I was about to take up that because what I can see is that we have most of the functional requirements already done. I was about to come to the non-functional requirement that let's see whether the system is able to scale for this much amount of load or not. So I would like to take up all of that one by one. So again, because of the fact that we wanted to ensure buy and sell is high consistent, so we have this consistent, I would say, more transactional compliant DBMS altogether. Now, for making sure that we are able to handle this much amount of scale, I believe we need to do optimization on multiple levels. The first level of optimization, definitely, you see that you are saying, right, that we are bombarding this API again and again to the price service, and exchange processor now has a lot of things to do as well. So instead of this, what we can maybe try to do is, again, we could have a streaming platform in between, using which this exchange gateway processor can send that data to the streaming platform, and price service can subscribe to it. But the problem would be, again, this is definitely a good design, not too bad, I believe, based on the scale that we have. Because if, let's say, the streaming platform is Kafka, in 1 second we will be able to easily handle 10 is per 5 events altogether, and we have like, let's say, definitely lesser than that kind of like request we are handling. But the problem is that price service has to again and again go and poll the corresponding Kafka queue and like kind of like consume it. It's more like a pull model from the streaming platform. What it would be better is that instead of a pull model, we have a push kind of like a model, that we have a push based mechanism. And for that, maybe something like a Redis real time pub sub can actually help us, that whenever we have an update on the price, that a price update goes to the Redis real time pub sub, and Redis real time pub sub pushes it to the price service. So it will be all in all a push mechanism coming up here, and we do not have to bombard our price service directly altogether. That is one thing. Second thing is that again, it's not just that we have to handle these many requests, we need to keep the latency as low as possible. So a good strategy in stock broker platforms is that a lot of stock broker platform even do actually as well, that the infrastructure for this complete infrastructure for our stockbroker platform, this complete infrastructure can be actually placed in the same data center or whatever infrastructure this exchange is. Like, for example, let's say there is a dedicated data center in a particular region where NSE or BSE has deployed their servers. We can try to keep our servers also in the same data center, and maybe try to have a contract in a way that we have maybe as much as possible more wired connection directly to the servers. What this is going to ensure is that our overall turnaround time is going to be very less, latency is going to be very less, and we will be having much faster order fulfillment and much more faster, I would say, data flowing us through us. And one more thing is that even if we are not able to, let's say, get our servers in the same data center, at least we should try to keep in the same region, because there's a good chance that the majority of the load of the stock buying and selling is going to come up from one particular, let's say, country's region as well, right? So that is going to be one thing. Apart from this, I believe there should be dedicated provisions, there should be dedicated servers provisioned for let's say, I would say, hedge funds, and there should be dedicated servers provision for bigger platforms like fund platforms, which buys and sells in very high volume rather than the normal retail investors. So I believe there should be dedicated servers pre-provisioned in a warm, like a warm state, for those kind of hedge funds, because whenever their request is going to come up, their request is going to be in bulk, very high value, and we need to ensure everything is for done for them. So this horizontally scaled mechanism, we might have want to have a hybrid strategy here for both of these servers, that we cannot just rely on auto scaling, we would like to have pre-provisioned servers. And sometimes we can also do one thing, that let's say once because let's say sometimes what can happen is that one symbol is having very high trading volume, so a lot of traffic of one particular symbol can be redirected to one or two dedicated servers. So even the load balancing mechanism we might want to keep hybrid, that okay, instead of just, let's say, just equally distributing all of the load, all the stock data for one particular high volume stock is going through one price server, and that server is, let's say, maybe a extra large instance on EC2 that is able to take more load. So I believe a good amount of hybrid strategies should be there in order to identify how the load distribution should technically work. And talking about yep, again, because here as well, in the order DB, for our order DB here, if we want to ensure that okay, we are able to see past history of orders, we should try to do a couple of optimizations here. First of all, we should try to shard the DB based on order ID, that user ID, that all the one user orders are going to one shard. That should be there, and every shard maybe we can try to index with respect to the timestamp, so that we are able to get, let's say, the last 30 orders and last 40 orders altogether. So I believe good sharding strategy should be done here as well, and in the time series storage, I believe here as well. So yeah, those are some more optimizations that I'm able to directly think of.
Okay, Sanket, I think we are out of time also. Just one last question, and maybe just try to answer it in a few lines only. Let's say your stockbroker platform is very popular, right? And what is actually happening is that a lot of the traffic and a lot of, I would say, lot of traffic in a very short amount of time is just coming from your stockbroker itself. How are you going to limit the ordering? Is that something you will take care of, or is that something the exchange should take care of in case of a very high surge number of orders from a particular stockbroker that has been built by you, and how would that work?
So again, multiple things can be done. For example, I believe the exchange might be already doing a bunch of things around the rate limiting on their aspect. First, second, this exchange gateway processor that we can have dedicated rules done on this exchange gateway processor. That let's say when they are, because if you see the orders that we are submitting, the orders are coming to OMS. From OMS, we are putting it into a streaming platform, and this exchange gateway processor is one by one picking up the order, or let's say whatever number of instances we have. Based on that, we'll be able to pick up the order. So we can try to tune in this platform in order to ensure that we do not bombard our exchange with a lot of order requests. That's why this streaming platform is going to help us put a lot of good amount of back pressure. So that is going to be there. Apart from that, if we see a surge of let's say price history kind of like data, then again, because of this storage, we can try to at least show something to the user, and we do not want it to be highly consistent. So we can try to limit the amount of requests that we are sending to the exchange for subscribing to, let's say, the stocks. We can also ensure that we have high priority obtained for some particular symbols, let's say the top symbols on large cap, mid cap, small cap, and let's say those are going to be something that we cannot get very stale data on. But there are some symbols for which even we are getting some stale data, we are okay with that. So I believe this mechanism that we have in place should be able to handle a lot of things for limiting up our data to the exchange. And we can have rules applied for the exchange gateway processor, that maybe because what I can see is that maximum amount of surge on these kind of brokerage platforms are going to come up at two times. One, when the market session starts, and when the market session is about to end. So we can have dedicated server provisioning done for that particular amount of time, that okay, that we are going to see a high amount of order load, and at least we can start accepting the order, but those order can be processed by the exchange later. So because of this asynchronous mechanism, we will be able to limit the amount of orders, I believe. That would be again one good way to think of.
Okay, I think we're done. Thank you so much for this design. I think it looks good, and thank you for it.
Cool. Yeah, thanks Ria, thank you for your time.